In this lecture, presented by www.free-academy.com, we're going to be doing a review of lines and slopes. Now, I'm sure you guys have seen this a million times back in algebra and pre-calculus, so we're going to breeze through this really quick. We got 4 different ways of writing lines. The one that you're probably most familiar with is the slope-intercept form. That's where you have the y value, or as always the f of x value, equals the slope times x plus the y-intercept. When x equals 0, the value of y would simply equal b. Then you have the point slope form, the double intercept form, and the general form. When you get into multivariable calculus, you're probably going to be working with the general form the most. This is also can be extended if you did ax plus by plus cz plus d. That would be the equation for a plane. Notice also that this is a polynomial of first degree. What that means is if a first degree polynomial means that your largest power of x is 1. If it was second degree, then your largest power of x would be squared. Third degree, you would have an x to the third. But keep in mind, if you had a first degree, you would never see an x squared. If you had a second degree, you would never see an x to the third or x to the fourth. And if the degree is the largest exponent value of x. Either way, a little off topic there. Interesting. So those are your equations of the lines. We're not going to really do anything with these except for the slope-intercept form of the line. I'm going to bring up a new note here, even though I really like the color of the old one. And let me rewrite this as f of x equals mx plus b, with m being the slope. The slope is a surprisingly important topic in calculus. So I'm going to really try to emphasize this and try to explain it as clearly as I can, even though I'm sure you've all seen this before. Mathematically, it is defined as the change in y over the change in x, which the formula becomes y2 minus y1 over x2 minus x1. If you were to make a graph, let me change my color here. I always have trouble making square graphs on this tablet. Alright, here we go. 1, 2, 3, 4, 5. 1, 2, 3, 4. Let me draw 2 points here. 0, 1. 1, 2, 3, 4. And another point, 4, 3. And let's create a line that connects through these 2 points here. We can figure out what the slope of this line is by plugging into our equation. We got 3 minus 1 over 4 minus 0. That's going to give us 2 over 4, or equals 1/2. And this is the rise over the run. We'll draw a little triangle here. Notice this triangle goes up, changes 2 blocks of y, and 1, 2, 3, 4 blocks of x. So we've raised up 2 and over 4. 2 divided by 4 is 1/2. So for every 1 increase, let me grab a different color. For every 1 increase on the y-axis, we have a 2 increase on the x-axis. Alright, so if that was difficult for you, then you'll probably want to really review algebra. But the reason why I was really driving this home is because we're going to come up, let's call that a parabola there, with something called the derivative, and that's where we're going to find the slope that intercepts exactly 1 point on the graph. That's called the derivative in calculus. So that's yeah, just if you can do slope, then you will have no problem. If you understand the slope is the change in y over the change of x, then you have no problem. So there really isn't anything else to that. The one thing that the book says here, and I guess I'll go over it for completeness, is the angle of inclination of the line. And that is the measure of the angle of the line from the x-axis. And that's typically denoted by the variable phi. And the equation for this is that the tangent of phi equals the slope. That's everything for this chapter, so hopefully everything was helpful for you guys.